Hello viewers, today being the 2nd of September the year 2023, we are going to discuss some questions on the topic Calcalus. This is the third part of the topic. We are going to tackle some question on the topic Calcalus. But before we continue, we have to look at the summary. We have the summary concerning our topic of study. We have got the summary. This is our summary. This is our summary. It is important one should study the summary before diving to the questions. This is the first phase of the summary on Calcalus. This is the first phase of the summary on Calcalus. And this is the second phase of the summary on Calcalus. This is the second phase of the summary paper on Calcalus. One should study this summary before diving into the questions. Calcalus questions are more technical. One should understand the summaries first before diving to the question. This is the third phase of our summary. This is the Calcalus summary. For our learners, I think they should be very keen on the summary before diving to the real questions. Our topic of study today is Calcalus. We have copied the questions from the book made familiar, cases made familiar. I think we have showed you several times that our questions are from the KCSE revision books made familiar. As you can see, all these questions are Calcalus questions from the book KCSE revision made familiar. For our learners who are possessing this book, they can directly enjoy our lessons, as every question is done step by step. We have made our effort to do the questions in step by step. By the way, I think I should show you that it is your duty to be keen and study. The questions are as follows. This is question number 11 because we are going to start at question number 11 before we proceed to the other questions. Question number 11 states that a square sheet of metal has an area of 100 square meters. An open rectangular tank is to be made by cutting equal squares from the corners and bending the sheet up. Find the height of the tank. Find the height of the tank for which the volume will be maximum. Okay. From my solution, I made a sketch diagram. Then this is the sketch diagram that I made. Then for this question, we have to identify whether it is an integration or a differentiation question. But for our case, I read the question again. A square sheet of metal. This is sheet of metal. A square sheet of metal. A square sheet of metal has an area of 100 square meters. An open rectangular tongue is to be made by cutting equal squares from the corners and bending the sides up. Find the height of the tank for which the volume will be maximum. My sketch diagram, it shows that now from the area given is 100 square meters. It means that it is then cut from the corner. Understand from my solution and the diagram, this is how the sketch should be, because the square, the whole area is 100 square meters. Then if you square 10, which means that you are going to square 10 meters for each side. This is the square area. Then from each corner, there are squares are cut from each corner, as you can see from each corner, which the length is not given. Then we have said that the length should be x. We have labeled the length to be x. Now, I have said it earlier that we are going to identify whether it is an integration or a differentiation question. For this case, this is an integration question because we are looking for or calculating of an object. If you want to know more about this, focus on my summary. Full detail are given in my summary tips. Remember, this question is opposite of question number 7. You will, if you see from my previous video, question number 7 is opposite of this. Question number 7 is a differentiation question, but this is an integration question. Therefore, we say that let the small square cut from the corners, each of their sides be x. As you can see, the whole square is 10 meters, the sides is 10 meters, 10 meters. But we say let the small square cut from the corners, each of their sides be x meters. Then the dimension of the tank will be, say that the dimension of the tank will be 10 into brackets length of one side of the square, length of one side of the square, which will be, not really, this will be 10 minus length of one side of the square, which is minus x minus x minus x minus x minus 10 minus brackets x minus x, then times x, then we say into brackets times x. Note this denotes times x. This will further give us 10. This will give us 10 minus, because this will give us, sorry, this will give us, we say that this will be 10 brackets length of one side of the square into brackets minus x plus x into brackets meters into brackets meters times unknown height times height this is times height this is these are unknown length from the two corners. So it's 10 into brackets length of one side of the squares minus x, the length of the unknown, minus x, the unknown length of the two corners of the sides, which are in meters times height, which this will be x, which is also unknown. The height is also unknown. Therefore, this will now give us 10 minus 2 minus x into brackets times x. This is because we initially had 10 minus brackets 2 minus x into brackets times x. This gives us this. Therefore, we say if the length of one side is 10 minus 2x into brackets meters, therefore, considering the information above, it's a square cube, hence the base length must be the same. Therefore, volume is the same as length times height, which will give us 10. This is our length, 10 minus 2x times 10 minus 2x times x, which is a single height, length times height, which is x. Therefore, we are going to expand this. This will give us, by expanding that, it will give us volume will be 100 minus 80x plus 12x squared. After solving this, this is a quadratic equation. By using the quadratic formula, you are going to get your x to be 5 meters. Because this is a quadratic formula, we are going to get 5 meters or 1.67 meters, and this will be the answer. After solving this quadratic formula, you are going to arrive to that answer, and that is how question 11 should be done. We are in question number 12. This is question number 12. Question number 12 states that This is question number 12. Question number 12 states that a closed cylindrical container designed such that its volume is 250 pi centimeter cubic is made from a metal sheet. Find the volume of the container, which will require a minimum area of the metal sheet. 4 marks. For this question, note that wherever you see the term maximum or minimum area in either land, sheets of metal or wood, note that it's a differentiation question. Therefore, for this case, the surface area of the cylinder in relation to its volume by substituting with the value given with both the surface area formula of the cylinder and the formula for the volume of the cylinder. Therefore, the surface area of the cylinder is given by the formula 2 pi r squared plus 2 pi r h plus 2 pi r h. 2 pi r squared plus 2 pi r h. This is how we find the surface area of the cylinder. I think we used to work out this when we were in the primary school level in grade 7. If you refer to the book grade 7, you'll find this formula. Hence, the volume of the cylinder is also given as pi r squared h. Refer these formulas in grade 7, the primary school course book. This is how we find the volume of the cylinder. Now, our volume is given to as 250 pi. Hence, if 250 pi is the same as pi r squared h, we are looking for r. We are looking for r now. Therefore, r will be pi r squared h over 250 pi. Because we are looking for r, we are going to divide both sides by pi, so that if we eliminate pi, we get r as this is our r. We are going to get r squared h as 250. Therefore, here we get our r is, we were finding for r, but now r is r squared because there is this r here. We say r squared h is the same as 250. We divide both sides by r squared. If we divide both sides by r squared, this is r squared. Now r squared will cancel. This will go with this, but this one will remain because it's over 250. They cannot cancel. Therefore, we get h as 250 over r squared. By substituting by substituting h in the surface area formula, we get by substituting h, we get 2 pi r squared plus 2 pi r times 250 over r squared. Therefore, we say 2 pi r squared plus 2 pi r times 250 over r squared This will further give us 2 pi r squared plus 2 times 250 pi r. Now we are going to divide this by r squared, which will further give us, 2 pi r squared into brackets plus 500 pi r over r squared. This will go, this will go, this will give us, this will further give us 2 pi r squared plus 500 pi over r. I hope you are following me. Then we proceed as, we say 2 pi r squared plus, we are going to continue it here. We're going to say that 2 pi r squared plus 500 pi is equals to r, because 500 pi over r is the same as 500 equal to r or divided by r. Now if r crosses equal sign, because negative, if r crosses equal sign, because negative, hence it will affect the whole equation, hence it becomes, this will become, 2 pi r squared minus 500 pi which will be -1. By differentiating this will give us, 4 pi r minus 500 pi r power -2. Because we are differentiating, we are going to say TAGR, change in area over change in radius. Hence our dA over dr will be 4 pi r minus 500 pi over r squared but for maximum area, for maximum area, we say dA over dr is equal to 0. Therefore, we say that this was number 12. Therefore, we say that question number 12, loop speed. Therefore, we say 4 pi r. This is 4 pi r minus 500 pi over r squared is equal to 0. This will further give us 4 pi r minus 500 pi over r squared. 500 pi times r squared is equals to 0. This is under brackets. Sorry, the brackets is all over here. All this part is under brackets. Then we say 4 pi r minus 500 pi is equal to 0. We say 4 pi r power 3 minus 500 pi is equal to 0 over pi. Now, this is 0. Note that pi goes. Therefore, we are remaining with 4 r power 3 minus 500 is equal to 0. This will give us 4r power 3 is equal to 500. This will give us, we are going to divide both sides by 4. Divide by 4, divide by 4. If you divide by 4 is 1, and if you divide by 4, this is 125. Therefore, r power 3 is the same as 125. R power 3, this one will give us the cube root of 125. The cube root of 125 is 5. And I think from the question, find the radius of the container which requires the minimum area of the metal. The radius of the container is finally 5 centimeters. The radius of this container is 5 centimeters from our working. Now you should be keen. You should be keen following our working. You should be very keen following our working. We have seen that the radius of the container is 5 centimeters. And that is number 12. That is number 12. That is how number 12 is done. And we are done with number 12. We are going to look at question number 13. Because we are done with question number 12. question number 13 states that a man has 140 meters of wire mesh. A man has 140 meters of wire mesh with which he intends to fence a rectangular enclosure for rearing hens. Find the length of the enclosure which will give maximum area, and hence calculate this area of 4 marks. Let me repeat the question. I read the question once more. A man has 140 meters of wire mesh with which he intends to fence a rectangular enclosure for rearing hen. Find the length of the enclosure which will give a maximum area, and hence calculate this area, 4 marks. We say solution. Now, before we dive into the question, we have to identify whether it is an integration or a differentiation question. This is question number 13. Now, this is a differentiation question. This is a differentiation question because of the term maximum area. Therefore, let the length, let the length required be L and the height be and the width be W. Sorry. Let the length required be L and the width be W. The rectangular enclosure with a total length of 140 meters. This is defined by the perimeter. Hence we are going to say that this is a rectangle. This is how a rectangle is drawn. First of all, you should know the figures. This is a rectangular. It is 140 meters. The plot is in a rectangular form, but the length of the wire is 140 meters, which should surround this. This thing defines, we are looking for perimeter here, and for perimeter they have mentioned area, but we are looking for perimeter because perimeter is the distance around the figure, and this is a wire which will surround the whole figure. Hence we say from our early knowledge of mathematics, we know that to find perimeter of a rectangular figure, we say it's given by, we are going to add the values of the two length and the two width, but we can derive it as formula. The general formula for perimeter of a rectangular is given by 2 into brackets length plus width, which for this case give us 140. Therefore we say but the length is not given. We have been given this area. Now for us to get the length, we have to divide both sides by the 2 here. Hence we say that if we divide everything by 2, we get length plus width. Length plus width will give us 70 here. Because we need length in maximum area, we have to find the width first. Hence width is given by 70 minus length. Note that by finding the width first, it's the only way of differentiating differentiating the length, but we know that area is given by length times width. Hence length times brackets, our width will be 70 minus L, which will give us 70 L minus L squared. This, by differentiating the length, we say change in area over change in length, which will give us 70 L minus L squared. This should give us, because we are differentiating, we say multiply by 1 times 70L, because this is differentiating, so read this minus 1 minus 1 minus 2 times L minus, this is 2 minus 1. We are differentiating. This will further give us 1 times 70 minus 2L. This will further give us 70 minus 2L. Okay? If you have forgotten on how we differentiate, you can see our previous videos. Okay, if we reach this step, we are going further through. We say, okay, but we know that for maximum area, it's change in area over change in length, which this will give us TA over TL will be 0. Hence, 70 minus 2L is equal to 0. This will give us, it will further give us, by dividing both by 2, this will give us 35. This will give us 2 minus L, 35 minus L. Therefore, 35 minus L. Then we are going to continue here as, therefore, the area required is derived from our initial equation as area is the same as 70L minus L squared. This is our initial equation, which will further give us 70, from our initial equation. That was giving us 70, our L was 35 times 35, which is squared, 35 squared. This will finally give us 70 times 35 squared. Not really. Here we say that, area is given by 70L minus L squared, which will give us 70 times 35. This will be into brackets minus 35 squared, because we have to derive it from our initial equation, and this is where we are going to get the correct answer. This will give us 70 times 35 minus 35 squared. This is minus 35 squared, minus 35 squared. This will finally give us 12 25 meters squared, and this is the required answer. That is the required answer. That is the maximum area. Find the length of the enclosure that will give us the maximum area. Now this is the length that will give us the maximum area. This is the length of the wire that will give us the maximum area. Now we are going to the final question. This is the final question. Question number, not really the final, but the second to final, question number 14. Question number 14 states that Question number 14 states that a particle P moves in a straight line such that a particle P moves in a straight line such that t seconds after passing a fixed point Q, its velocity v meters per second is given by the equation v is equal to 2t squared minus 7t plus 12. Find A, the value of t when p is at rest 2 Mach. B, an expression for the distance s meters moved by p after t seconds 1 Mach. C, the total distance traveled by p in the first 3 seconds after passing point Q 3 Mach. D, the distance of p from Q when acceleration is 0 4 Mach. Okay, question number 14. Okay, I think these questions have no formulas. You have to know the key points on my short summary so that you can tackle the question. They look as easy because they don't have formidable formulas. Okay, for part A of the question, we know when calculating calculus question under differentiation and integration, then the question could be asking displacement S, velocity V, acceleration A, or even dy dx in the gradient function of any curve. First, note that you are given a displacement and you need velocity. You differentiate displacement to get velocity, and if you are at acceleration and you want velocity, you integration. You acceleration, you want second velocity, not first. When you are given displacement and you need velocity, you differentiate displacement to get velocity, and if you are given acceleration and you want velocity, you integrate. Second, when differentiated velocity to get acceleration, if you are given velocity and you need displacement, you integrate. Third, if you are given acceleration and you need displacement, you need to integrate 2 times. For more about this, see my summary tips. Everything has been well explained. Therefore, for our case, we say, in short, we say this is distance, velocity, acceleration, and dy dx. Now question number 14. We know when the particle is at rest, its velocity is always 0. When particle is at rest, its velocity is always 0. Therefore we say velocity is 0. Hence velocity is given by t squared minus 7t plus 12 is equal to 0. The function is in quadratic equation in nature, then we are going to use any quadratic formula method. Note that this is the only type of quadratic type of question in which you are not going to require integrating. You are not going to require to integrate or differentiate in calculus at its first part of the question. Therefore, we say that t squared minus 7t plus 12 is equal to 0. Therefore, p is the same as 12 and s is 7. Factors are 3 and negative 3, and negative 4. Negative 3 and negative 4. Therefore, t squared minus 7t plus 12 is equals to 0. T squared minus 3t minus 4t plus 12 is equals to 0. By factoring out t because it's common, we say t to brackets t minus 3 minus 4 into brackets 4 is common in positive 12 minus t minus 3 times t minus 3 is the same brackets 12. Hence t minus 4 into brackets t minus t minus 3 into brackets is equals to 0. We have to choose t minus 4, t minus 4 is equal to 0, t is equal to 4, or t is equal to 3. Or t minus 3 is equal to 0, where t is 3. So t can be 4 seconds or 3 seconds. This means that the particle is at rest when time is 3 seconds or 4 seconds respectively. When time is 4 or time is, and that is the answer. That is the answer for question number 14A. For question number 14B, this is the answer for question number 14A. For question number 14B, an expression for the distance s meters moved by the find an expression for the distance s meters moved by p after t seconds. Okay, 1 mark. Distance here means displacement. Hence, if you have velocity and you need displacement, you integrate the velocity function. See the formula tips. Therefore, we say velocity is t squared minus 7t plus 12. Now, to get displacement, you have to integrate the velocity equation above. V is equal to t squared minus 7t plus 12. Hence, displacement is given by, we put the integration sign brackets, t squared minus 7t plus 12 to brackets dt. We integrate the velocity function with the respect to change in time. Therefore, we say that t, because we are integrating, t squared plus 1 over 3 minus 7t 1 plus 1, because we are integrating over 2 plus 12t. Because we are integrating, this will give us t power 3 over 3 minus 7t squared over 2 plus 12t over 1 plus the constant of integration c. But we know that when t is 0, our displacement will be 0, or we say s is equal to 0. For this reason, it will affect the constant c to be 0, or we say c is equal to, c is equal to 0. Therefore, we say that we're going to say displacement is given by t power 3 over 3 minus 7t squared over 2 plus 12t. This is the answer. This is the answer. And this is the expression needed, and this is the final answer. This is the final answer, and it is the expression needed. And it is the expression needed. We are going to part C of the question. I think you are following me. We are going to part C of the question. Part C of the question states that the total distance traveled by P in the first 3 seconds after passing point Q. Okay. For this question, we say that because here we are going to take our final displacement expression, final answer in part P, which is S for displacement is equal to 3 over 3 minus 7t squared over 2 plus 12t. Then we say at t is equal to 3 seconds, the displacement will be 3 power 3 over 3 minus 7 into brackets 3 squared plus 12 into brackets 3. This will further give us 27 over 3 minus 63 over 2 plus 36. this will further give us 9 plus 36 minus 31.5, and this will finally give us 13.5 meters. 13.5 meters, and this is the distance traveled by P in the first 3 seconds, and it is the answer required. We are going to question number 14D. Question number 14D states that the distance of P from Q when acceleration is 0 for max. This will give us, we have been given the velocity function to be v is equal to t squared minus 7t plus 12. Hence, we need acceleration here. Therefore, we need to differentiate velocity to get acceleration. Therefore, velocity is t squared minus 7t plus 12, which will give us 2t minus 7, which gives us 0. 2t minus 7 equal to 0. This will further give us 2t is equal to 7. If we divide both sides by t, we are going to get t as 3.5, which is 3.5 seconds. Hence, the acceleration is 0 when it's 3.5 seconds. Therefore, distance or displacement here substitute time to 3.5 seconds to the displacement function, which is the expression in part B of the question. This will give us displacement is given as t power 3 over 3 minus 7t squared over 2 plus 12t, which will further give us, this will further give us 3.5 all power 3 over 3 minus 3.5 into brackets times 3.5 times 3.5 squared plus 12 into brackets 3.5. This will further give us this will further give us by calculating using calculator, we see that our displacement will be 14.29 minus 42.88 plus 42. This will further give us 14.29 plus 14 minus 42.88. This will further give us our final answer as, if you add 14.29 plus 14 minus 42.88, you will finally get our answer as 13.41 meters. This is the final answer. Please subscribe, click the small bell ones download, then share to your friends and relatives. We are winding up this part of we are going to question number 15. This is question number 15 and it is the last question. It is the last question. Question number 15 states that a diver leaps from a diving board 32 meters above the surface of a swimming pool. At a time t seconds, his position h above the surface of the swimming pool is given by h is equal to 32 plus 16t minus 16t squared. Find a, the time he took to hit the water surface, b, the velocity at which he hit the water surface. Okay. Question number 15. We are going to, this is our last question of our part 2 of this video. I think this will be the last video on Calcalus. By identifying the question, it's a differentiation question because we are told that the diver finally rested or hit the water surface. Note that when you realize any action, any occasion where the term at rest is mentioned, know that it's a differentiation question, and we always know that when a particle is at rest, dy dx is 0 at water surface, hence 0. Therefore, we replace height h with 0. Hence, our height will be we say height is 32 plus 16t minus 16t squared. Therefore, 0 is the same as 32 plus 16t plus 16t squared. Then divide the equation through by 16. Hence, say, by dividing the equation through by 16, by 16, by 16, by 16, by 16, say that, okay, sorry, this cannot be 0, cannot divide 16 by 16, 1 by 16, 2. This goes, hence we're going to remain with 0 is the same as, because this is automatically 0, this gives us 0 is 2 plus t plus 2 plus t plus t squared by multiplying through by negative 1, so that we can start with the equation. We can start the equation with the highest value of t. We have to multiply the whole equation by negative 1, so that we can start the equation with the highest value of t. Therefore, we say t squared minus t minus 2 is equal to 0. We are looking for two numbers in which product will be, sum will be negative 1 and product negative 2. Sum will be negative 1 and product negative 2. And the two factors will be here. Our sum is negative 1, product negative 2, and hence the factors are 1 and negative 2 and negative 2. Therefore say t squared minus t minus 2 is equal to 0. Therefore t squared minus t minus 2t minus 2 is equal to 0. We are going to factor out t here, t into brackets t minus 1. We are going to factor out 2 minus 2 into brackets t plus 1 is equal to 0. Since t minus 1 is common, we choose only 1, hence t minus 2 into brackets t plus 1, which is equal to 0. This will further give us t minus 2 is equal to 0, which will give us t is equal to 2 and t plus 1 is equal to 0, which will give us t is equal to negative 1. The time, therefore, we know that time cannot be negative. Therefore, the time taken to hit the water surface is 2 seconds. Hence, the time taken to hit the water is 2 seconds, since time cannot be negative in the next part. In t is negative 1. Hence, the answer is 2 seconds. The answer is 2 seconds. This is question number 15A. Question number 15B states that we are going to find the velocity at which he hit the water surface. Velocity at which we hit the water surface. From the initial equation, h is given by h is 32 plus 16t minus 16t squared. Note that this is also the displacement, but velocity is given by change in displacement over change in time. When our height is h, we are going to differentiate h against time. Therefore, dh dt is given by velocity, which is 0 plus 16t, but we are differentiating here, minus 1 minus 16 t squared minus 1. We are going to get 16t, t is power 0 minus, this is 32t. We are differentiating n number power. If t is power 0, n number power 0 is 1. Therefore, it's 16 times 1 minus 32t. Now, to get the velocity in which he hit the water surface, we need to substitute the time t to the expression. The expression 16 minus 32 t. From the initial time he took to hit the water surface, which is 2 seconds, which this will finally give us 16 minus that 2 brackets 2 seconds, our time, which will give us 16 minus 64. This will give us negative 48 meters per second. Now our time here is in negative, then we say that this is retardation. This is retardation because he was slowing as he was going down as velocity was reducing. Note that not all figures must be used in calculating in calculus question, even if part of the question. For example, we have seen that there is this figure here. A diver leaps from a diving board 32 meters. It is not used in calculating this question. It is not used in any part of the entire question. This is our final answer. We should note that it is not important for you to use all figures as seen in question while calculating calculus. For my viewers, I would like to remind you to subscribe, click the small bell once, download the videos, share to your loved ones. But before I think we are going to end our calculations there. Next time we are going to look at other topics. I wish you all the best.